So here we go. On number 1, I want you to just tell me from these 2 points, 2 comma 3, and 10 comma negative 11, what the distance is and the midpoint. I'm going to pause for a second while you give that a shot. All right, so here's your next 2 problems, and let's see. I'll give you a few minutes to try that, and I'll pause while you give that a shot. So on this one, I would hope you had multiplied everything by not just 5, but also 3. And I know that's the same as multiplying by 15, but I say if you can factor it, you should. And so even 5 times 3 is better than 15. Because look, these 3's can cancel now, and these 5's can cancel now. And now I'm just left with 5 times 2 is 10, n plus 3 equals 10 times 3 is 30. Subtract 3 from both sides, 10n equals 27. And I think some of you guys know this, but when you divide by 10, you just move the decimal over and you get n equals 2.7. If you did it as 27/10, I'm okay with that. How many of you had the right answer for that one? Good. And let's go with Samuel. Would you please tell me your process for this? I'm curious. You the front Samuel, yes.
You can make 8 into
2 root 2, because it's really root 4 root 2, which is really 2 root 2. And then what?
Then you can factor it
Negative 1 plus and minus what? Good, that's the hard part right there. I'm going to just pause for a second. There was a 2 in this, and there was a 2 in that. So we factored them out to the front. And then that's all over 16. And now, if I factor the bottom, it'd be really smart to change 16 into 2 times 8. Okay, now that distraction in the back is done, did you get negative 1 plus and minus the square root of 2 all over 8? Raise your hand if you had that one right. Okay, cool. All right, so there's just some warm-up problems. Why? Because tomorrow we're going to be taking a top 20. I'm a big believer in having your basics completely down, much like a basketball coach that makes you keep shooting free throws so that you have it in the moment when you need it. Because if you're fluent and it's just like automatic to do your algebra, including things like fractions over fractions, you know, now you guys know why we did this. It was because it was like sine over cosine over cosine over sine. If you don't know how to do it with simple numbers, then why on earth, you know, like how on earth are you going to do something like that? So you had to understand it for simple numbers to be able to handle it when we did it in trig. All right, I'd actually like you to try that one right there, because that's absolutely something we could have done, except it wouldn't have been sine over cosine. What is sine over cosine actually? They would have had tangent over something else. But for right now, would you please just simplify this down? Well, one thing you could do is say sine over cosine times, and then flip the other one, sine over cosine. And that's sine squared over cosine squared. But then you might just want to say, well, each of these is really just tangent. So then it's just tangent squared. That would probably be as simple as you could make it. Raise your hand if you had that one right. Cool. All right, now I want you to grab the packet. Everybody take out the packet, have it in front of you. On number 4, come up. Pausing for a second. Okay, I'd like you to look at number 4. It says 4, 8, 16, ... meaning keeps going for a long time, and then 1, 6, 3, 8, 4. Well, hopefully you know how to use those formulas. The first thing you do is look at this and say, are they just adding 4 each time? No, they're not. They're multiplying by 2 each time. So that's geometric. then of the formula list, you'd look up the one for geometric, and then do we want to add them all up? No, it says how many terms are there. So like that's we need the term finder, all right? So the term finder for geometric. Davis, did you look up that?
A sub n equals a r to the power of n minus 1.
Perfect. And which of those do we know? Do we know a sub n?
Yes.
That is a sub n. So 1, 6, 3, 8, 4 equals, what's a?
Our first term.
Yep, which is 4 times what's r? 2 to the n minus 1. I still don't know n, right? And now I had somebody ask me before, how do you solve this without guess and check? I totally get this would be tricky. Now you have a calculator, right? So I would have taken, and I just use my calculator. I'm going to use Siri, but what is 16384 divided by 4? 4096 equals 2 to the n minus 1. Now, you know my favorite saying is if you can factor it, you should, right? Okay, can't factor that. What's my next favorite saying? I think the next most common one is clear out the fractions. Is there any fractions? No. So what's the one that is kind of rarely used, but when it is, it's super handy? Yes?
Rearrange?
Nope. Yes? Yes, you can absolutely rewrite this, but if you didn't catch that, this is something that would work every time, always on an equation, and everybody forgets it. Yes? You could do that too. There's nothing wrong with that. It's just hard to figure out what 2 to the what is 4096. You're right. That would work awesome. But this general rule, I obviously don't use it enough, is graph both sides and see where they cross. Do you have a calculator? You have a calculator. You're going to use a calculator on this test. On the whole final, you get a calculator the whole time. You could graph y equals 4096, and you could graph y equals 2 to the n minus 1. I'm not saying this is the easiest way of all. I'm saying it's a great way to do it, considering there's a lot of really smart kids in here, and 0 of them thought about graphing both sides to see where they cross. It's powerful. And what would it look like? Oh, it's going to be a line way the heck up there at 4,096, so it's going to be way off your graphing screen. And then here's the other equation. Y equals 2 to the any power. If you graph that, it's going to look like that. Okay, and then guess what happens? They cross, and then there's your answer. Yes? Yeah, absolutely. But couldn't you just graph both sides and see where they cross? My point is this can be used a million times, and logs can only be used when there's powers that are exponents. But this technique I just showed you of graphing both sides and seeing where they cross, that'll work in a million different cases. So since you have a calculator, and do you get on the ACT, you're going to have a calculator? So anytime you have something weird and it's an equation, you can just graph both sides and see where they cross. But if you want to use a log for it, and that's what Max said a long time ago, rewrite it as a log. So then it's log, and what of this stuff looks like a base? Hello. What out of that equation looks like a base to you? The 2. Okay, so then it's log base 2 of 4096. Is there a way to do that in your calculator? Absolutely. Equals n minus 1. And that is just a number, and your calculator can do it. I do math, alpha math. Pretty sure that's what gets you log base on your calculator. On your TI-84. And log base 2 of 4096. It also could be typed in log of 4096 over log of 2. In case you forgot that, that's called the base change. I just changed that to base 10. It was a base 2. Now it's a base 10. You just put The one that's higher of the two goes on top. The other one goes on the bottom. All right, that's enough help on that problem. It was a good question because it made you use logs at the end or graph both sides and see where they cross. Yes?
How would you just graph the original equation?
All right, let me just give you a simple one. Let's say I ask you to graph this. What I'm really saying is y equals 2x is an equation. You could graph that easy, right? And y equals 8, and that's another equation you could graph really easy, and you'd see just where those two lines cross. So you go to the y equals on your calculator and type it in. Now this one was more complicated, just really big number here, and I think this would have been the spot right here where I would have graphed it. I would have graphed y equals 4096 on your y equals button on your calculator, and y equals 2 to the n minus 1. And this one will graph really easy. This one's only weird because it's so high up on the screen, it's going to be hard to see. So then you just have to adjust your window on the calculator so you can see that high. So you'd want your y value to go all the way to like maybe 5,000. And then you can see where they cross. Okay. I want to spend a little time on anything off of the back side of the front page that you had questions about. Any of the 5, 6, 7, 8, 9, or 10 that you had questions about. Remembering you have a key. So you can totally look at the key. But if you looked at the key and you're like, oh, I still don't understand it, you can ask me. Yes?
Is it asking for a 33 or just like a number?
All right, so here's an example on number 10. When they say sine of 4 pi over 3. I want you to think for a second. Did they just ask you for the angle?
This is a value.
I know, but I can tell by looking at the problem. Did they just ask you for an angle? So let's analyze that a little further. Let's give you a nice simple one. Sine of 30 degrees equals a half. I asked you to memorize that one a long time ago. Another way they could write it if they wanted to use radians would be sine of pi over 6 equals a half. So look at this problem here. Do you get right after the word sine? That's where the angle is. So that's an angle. So when you asked me, did they ask me for the angle? Did they want the angle? Did they want the angle? No, they already gave me the angle. So you can tell by that they don't want the angle. They already gave you the angle. They want the side ratios, which is like opposite and hypotenuse. So how would I do that? I'd draw a picture. So 4 pi over 3. Now, this is 1/3 of the way to pi. 2/3, 3 pi over 3. And this is another pi over 3 gets you to here, and that's about where 4 pi over 3 is. And then I draw my triangle down there. And that's a 60. And I bet you can do it from there. So if I got a 30, 60, 90, I know this is a 1, 2, square root of 3 triangle. But, oh, most common mistake in circle trig, negatives. And if I want the sign of that, now that I got that drawn, Ashana, can you just finish it off and tell me what is the sign of that? Negative root 3 over 2. Good. See how they gave me an angle and I gave them the sides. Okay. You want to do another one?
How would you do the secant?
I wouldn't do secant. So as soon as they asked me to do a secant, like it says secant of pi over 4, do you remember these are the ones where I said just refuse, peacefully refuse to do secant, and instead, yeah, exactly. So you go, I'm not going to do secant, I'm going to do 1 over that.
Are we going to get the...
Don't do, I know you're really close to me, but raise your hand because there's a lot of people and it just is interrupting otherwise. So I got secant of pi over 4. I'm not going to do secant. I'm going to do cosine of pi over 4, but I'm going to do a 1 over here so that I remember that when I get my answer, I got to do 1 over that. You know what I mean? All right, so what is cosine of pi over 4? So then I go down here and make a pi over 4. That's 1/4 of the way to pi, so that's like here. And I can draw triangles from that. And that's a 45, so it's a 1, 1, square root of 2. And cosine is adjacent over hypotenuse. But then remember, I have an answer of 1 over root 2, but then I got to remember I was just doing secant, so I got to flip this. That's the 1 over thing. So my final answer for this one will be square root of 2. So do it like it's a secant problem, but remember at the end to flip it. All right. Excuse me. Do you have a question?
Yeah, did you get the relationship sheet, like the one that we used for this unit?
Not sine, cosine, and tangent, and you also don't get a list of, well, actually, wait. How about this? Why don't you look at what you get? Because I put it in the folder for yesterday.
Okay.
Yep, there's the sheet in there. Why don't you look in there and see if it's got on there what you want? And if it doesn't have what you want on it, put that on your own sheet that you should look at right before the final. I gave you one yesterday and I said, hey, you guys should write this down. Like this is the dead zone for inverse trig. This is where, which one lives up there? Arc cosine. So I gave you a start of a sheet like that. So that's where I would put that. If anything that you want to memorize but is not on the sheet we're giving you. So let's just finish this one off. This is where arctan is. And arcsine is very similar, but it touches. Okay. And this is the negative zone. Very common for kids to forget that if you're doing inverse trig, you got to give negative answers down there. All right, I think we're done with those 2 pages. Now let's look at 11, 12, 13, 14, 15, 16. Anything in there on the review packet that you'd like to talk about. All right, I want to do one last question that's a little bit like number 11. So everybody, try this with me. I know you're probably working on your packet, which is great. Stop working on your packet for a second and get a blank notability doc and try this. If I have secant, you're supposed to know what to do with this, of theta is equal to 2, and tangent of the same angle is less than 0, that's just a way of saying the tangent of the angle is negative, then what's the angle? Right away, I wouldn't use secant. Doesn't help me. So right away, I'd change that from secant to something else. And then I'd try to figure out which quadrant I was in. Then I'd try to figure out how to draw a triangle for this. All right, give it your best shot. I'll pause for a second while you do. All right, do you guys get that I was really saying that cosine of the angle is a half? You got to be able to translate those. Secant and cosine are sister functions, right? So then, if I'm drawing my triangles, I got to figure out where cosine is going to be a half. All right, so all students take calc. So where's cosine positive? That's all I really care about first, is that it's positive a half. So cosine's positive, not here and not here. And then tangent's got to be less than 0. Tangent's got to be negative. Oh, well, then it can't be here because the tangent's negative. It can't be there. So then I know it's here. You always draw a short, fat triangle, and then you label the sides. Cosine's adjacent, hypotenuse. 1, 2, square root of 3. I know this one. And across from the square root of 3 is where 60 lives. And I'd be really careful right this moment and say, am I supposed to be saying 60? No, I'm supposed to be saying pi over 3, because pi is like 180, and 180 over 3 is 60. So pi over 3. But then, is it negative pi over 3? Am I doing inverse trig right now? Did you see arc or negative 1 power? No. So it's not negative 60 or negative pi over 3. We got to go around this way. And it's a whole bunch of pi over 3s. 3 pi over 3 was here. So it's obviously bigger than that. 4, 5, 6 pi over 3 would be back to here, so that's too much. So then this is 5 pi over 3. Raise your hand if you had that one right. Cool. That's a lot like number 11, and it's a good review of tons of circle trig. All right. And it'll even work if these numbers hadn't been nice, if this had been like on problem 12, they just give you different numbers to put on your triangle. You do it the same exact way, you just have to label your triangle with different numbers. You just don't have that one memorized. So, all right. I think I want to just let you lead me with questions. So is there any other topic that you want to talk about? 11, 12, 13, 14, 15, 16? I think I want to stop there because we have lots of review days left and my voice is really hashed. So
Can we do 13?
number 13. All right, I'll do one like it, but not number 13. So I'm going to do a bike. I'm not even going to ask how many of you have ridden a bike because it's pretty much everybody. So most of the bikes that kids ride are in the neighborhood of 20 inches radius of the tire. Actually, yeah, it's a neighborhood of right, okay? So let's say it's 20 inches. Now let's say that it happens all the time, you get a piece of gum stuck to your tire, and then your tire goes around, it goes tick, 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 and you can kind of hear it hitting, okay? So let's say from that you're able to say, I'm doing about 2 rotations per second. You get how I set that up? I'd like you to change that into meters. Actually, no. Let's try to figure out how many inches. No, that's dumb. Nobody would say that in the real world. How many feet you're going to go in a minute. Change this to feet per min. Now, I know this is not the exact problem you have, but it's very similar, and I know what's on the test. So 2 rotations per second. I would right away go, okay, so I got to get rotations out of there. So right away I put 1 rotation on the bottom, and you are forced to think about, what is a rotation again? Oh yeah, it's a circumference. Do I know the formula for circumference? This is another one, pay attention, where I suggested you have a list of things that aren't on the sheet, but you still have to know. Circumference is one of them. You got that formula down? What's the circumference?
Isn't it pi d?
Pi d totally works. What's another way to say it with radiuses?
2 pi.
2 pi r is usually the way we say it, but you are correct. Okay, know those two. If you don't have those memorized, put it on your things to memorize right before the test. Yes? Louder?
May I go to that one?
Yes, you may. All right, so my next trick is to change 1 rotation into something. Well, 1 rotation is 1 circumference. So then it's pi times the diameter. Pi times not 20. 20 is not the diameter. Pi times 40. And I'm off and running. And that's in inches. And now rotations is gone. I'm trying to get to feet per minute. And I now have to multiply by a few other things to clear my inches. My inches I want to be gone, so I'm putting them there. And then what's a thing I want to replace it with? I want feet. Oh, 1 foot, 12 inches. Awesome. Now my inches canceled. Now I got feet per... Ew, what is that? Oh, seconds. Seconds is on the bottom. Feet per seconds. Oh, and my seconds I have to change into minutes. That's easy. So I put seconds here and minutes here. And what's a fact I know about seconds? 60 seconds in 1 minute. Seconds cancels. That's how you do that kind of a question. And now I just have to multiply all across the top, multiply across the bottom. You do have a calculator on this one. I would expect you to get a final answer as a decimal. It'll probably say where to round to. That should help you on number 13. It's very similar. Okay, any other ones that you want to ask about? Then, for today, the rest of the time is just work time. And you can come up and ask me questions. My voice is really trash, so I'm going to stop talking now.